The last intermolecular force we're going to look at is hydrogen bonding. It's the strongest, and it only occurs when we have hydrogen that is bonded to nitrogen, oxygen, or fluorine. And again, the hydrogen actually needs to be bonded to those one of those elements. The electrostatic attraction is between the partially positively charged hydrogen and the negatively charged nitrogen, oxygen, and fluorine. And again, this is actually a special case of dipole-dipole. Here, our hydrogens have a very low electronegativity, while nitrogen, oxygen, and fluorine have a high electronegativity. And so usually the nitrogen, oxygen, and fluorines have a partially negative charge. And so again, the hydrogen of one molecule is attracted to the oxygen, fluorine, or nitrogen of the other. Now, when you're drawing hydrogen bonds, make sure you draw them as those sort of like dashed lines. That's a very common question that the IB will ask. You sort of just draw them between the hydrogen and whatever other element, N, O, or F, exists on the other molecule. Now again, here when we're talking about boiling point and melting point, remember that things with hydrogen bonds are stronger. They have a stronger intermolecular force. And again, the more hydrogen bonds that you have, so the higher number of hydrogen bonds you have, the higher the boiling point. So if you take a look, here we have one possible hydrogen bond, here we have two possible hydrogen bonds in the second molecule, so the second molecule will have a higher boiling point. In terms of solubility, it's quite similar to dipole-dipole. The greater number of hydrogen bonds, the greater solubility in water. And again, this is due to this idea of like dissolves like. Because water itself has hydrogen bonds, it is able to dissolve things that also have hydrogen bonds.